Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework. The closure problems 123 through 126 are what were assigned yesterday. So let's look at problem number 123. We got Rafael, 5 hits and 7 at bats. If he continues with this pattern, how many hits will he have in 210 at bats? So we're going to set up this ratio, 5 hits for every 7 at bats, assuming he's going to continue at this pace. We have to identify what the giant 1 multiplier is going to be. What would you multiply times 7 to give you 210? Whatever you multiply times 7 to give you 210 will also multiply times 5 to give us x. Now this is probably the easiest way of doing it. We know that 7 times 3 is 21, so that means our multiplier is going to be 30. And 5 times 30 is 150. So that would work. We would expect Rafael to get 150 hits if he continues hitting at this pace. Sometimes, however, the giant 1 is not really easy to figure out. So one way that always works is cross multiplying. If you cross multiply, you end up with 7x's is equal to 5 times 210. That would be 1050. And now you solve this one-step equation by dividing by 7, and I guarantee you 1050 divided by 7 is going to give you 150. And there it is. So I like this method because you could have decimal numbers in here. You could have crazy, ridiculous numbers, and the cross products, first you cross multiply, then you divide process, will always get you to the correct answer, provided you do the calculations correctly, but then use your calculator and you shouldn't have any mistakes. But I would agree that sometimes just finding a giant 1 does seem like the easiest thing to do, so that's what we could have done here. Solving this equation and recording your steps. So instead of saying 6 minus x minus 3, I would rather write that as 6 plus a negative x plus a negative 3, because that allows you to combine like terms easily. So that becomes negative x, remember that minus sign is attached to the x, plus a positive 3, since 6 minus 3 is 3. And on the right side, we got 4x minus 12. So at this point, since I've got more x's on the right, I would probably just add 1x to each side. And since I'm collecting my x's on the right side, well, I guess I did this in 2 steps, didn't I? So we rewrote this as 3 equals 5x minus 12, but you could have added 12 to each side here as well. And you would have gotten, eventually, 5x is equal to 15. So at the last, what do you multiply times 5 to give you 15? Well, whatever 15 divided by 5 is, and that answer is 3. So we can plug that in to make sure that it works. 6 minus 3 again is going to give you 0, correct? And on the right side, 4 times 3 is 12, and 12 minus 12 will give you 0. And since those balance out, we know that this has to be the solution. Make an XY table for the points on the right, and then write the rule for this situation. Okay, so when we get into chapter 4, we're going to work more closely with how to create a rule from a graph. First thing we do is we identify, all right, there's the y-intercept, that's 0, negative 5. That would go here. And then this is 1, negative 3. And this is 2, negative 1. And what you start to realize when you put this into a table, that there is a counting sequence. And what is happening between each one of these is these numbers are increasing by 2 every single time. And then remember, the y-intercept is a very important number, because when x is equal to 0, whatever y is has to be this number that's being added on at the end. So we're going to combine our growth rate, which we multiply times the x, and our y-intercept, which is added on, or in this case subtracted, at the end, and we get a rule that says y equals 2x minus 5. Now let's make sure that that works. Let's test it right here. What's 6 times 2? That is 12. And 12 minus 5 is 7. So yes, it works for this one. Let's try it here. What's 2 times negative 1? 2 times negative 1 is negative 2, and negative 2 minus 7, no, minus 5, is negative 7. So that works for this one as well. So if it works for a couple of them, it'll work for all of them. This is definitely the rule that applies to this graph. And the last problem, Jessica was solving an equation. And after she finished simplifying, her result looked like this. So I don't know what the equation looked like, but let's just think of it as something like x plus 1 is equal to x plus 3. If you take away an x from each side, you get 1 equals 3, and then when you take away 1 from each side, you would get 0 is equal to 2. Well, does that make sense? Is 0 equal to 2? No, it's not. Neither is 1 equal to 3, which means that x plus 1 can never be equal to x plus 3. There's no value for x that will ever make that a true statement. So that means there is no solution for this particular equation. Alrighty? All right. I guess our next thing to do now will be to move on to our study guide to fully prepare for our chapter test, which will be taken tomorrow. All right, let's get to it. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,